Alright guys, so we're going to talk about curve sketching. The keyword here is sketching. And this is going to be when we're given a curve like f of x equals whatever, and we have to then sketch it out. So things to think about: x-intercepts and y-intercepts are really important. Symmetry is nice to know, but it's not as important as domain and vertical asymptotes and horizontal asymptotes. And those are all things that we can find from the original from f of x. Then we want to know, okay, how is this graph increasing and decreasing? So we find those relative extrema from f prime, our first derivative. And then finally we think about concavity, which is our second derivative. And just quick refresher would be that x-intercepts, right, we set f of x equal to 0. Y-intercepts, you plug in x equals 0. Domain, you can't have square root of a negative, so we would set something inside of a square root greater than or equal to 0. And the denominator is not allowed to equal 0. If you combine both of those, you just set that term greater than to 0. Okay, vertical asymptotes are when the denominator is equal to 0. Horizontal asymptotes, we learned, were when we take the limit as x approaches infinity. And then relative extrema and concavity we've been doing. So a first example would be sketch the curve f of x equals 3x to the fourth minus 6x squared. So first I want to do anything I can do with that f of x. So that's going our x-intercept, y-intercept, vertical asymptote, horizontal asymptote, and the domain. So in this case, the domain of this is all real because it doesn't have a square root or anything. And similarly, the vertical asymptotes, there won't be any. Horizontal, when we take this limit as x approaches infinity, it's equal to infinity, so there are no horizontal asymptotes. And then x-intercept, we're going to set our graph equal to 0. And so I'll factor out a 3x squared times x squared minus 6 equals 0. And we'll get x equals 0 or x equals plus or minus radical 6. Oh wait, that's a 2, sorry. So plus or minus radical 2. So we'll plug those in. We'll get 0 comma 0, radical 2 comma 0, and negative radical 2 comma 0. And then our y-intercepts, we plug in 0, and we get 0, 0. So this is everything we can think about for the x. So when we're starting to graph this, we can start to make those points. 0, 0 is going to be on my graph. There's 1, 2, radical 2, 0, right? That's bigger than 1, smaller than 2. And it's actually about 1.4. So that'll be in there. And same for negative 1.4 radical 2. So those 3 points are in there. And this one's kind of repeated. So that's everything we know so far just from the original. Now we're going to get into the derivative. And our derivative will be 12x cubed minus 12x squared. And now we'll set that equal to 0. I'll factor out a 12x squared. That leaves me with x minus 1. So I get x equals 0 or x equals 1. And these are for my critical points. So those are the critical points. And when I put those on a number line, 0, 1. So less than 0, like a negative number, that'll be positive, and then I'll do this in a new color. Positive, and then negative, so that's negative. In between 0 and 1, like 0.5, positive, still negative. And then greater than 1, like 2, positive, positive. Oh, you know what? I just realized I actually made a mistake. So this was, derivative should have been 12x cubed minus just 12x, right? Because that's 12x. So that was my fault. So when we set this equal to 0, say 12x times x squared minus 1, and we get 0 equals x, or x equals positive or negative 1. So we have negative 1, 0, positive 1. And now when we plug these in, what we should get is we'll get negative, positive, negative, positive. So now we know those intervals, and I like to just kind of draw at negative 1. It's not really an asymptote, but I just know it's going to change from negative to positive at those lines. And then I do my second derivative, and my second derivative will be 36x squared minus 12. Factor out of 12, we get x squared minus 1. Set that equal to 0, and x equals plus or minus 1. And we'll do that number line, negative 1, positive 1. And below negative 1, we'll get positive. And then in between negative 1 and 1, we'll get negative, and then positive. So I know that this section of my graph, below negative 1, is concave up and decreasing. So when I start to sketch this, it's coming down, 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 but it's concave up. It's curving up. And then at negative 1, it switches to concave down, and it switches to positive. So now it's concave down, but it's increasing. Now from 0 to 1, it's still concave down, but now it's decreasing. Then at 1, it changes to concave up and increasing. So my graph is going to look like that. Now I want you guys to practice this, so those of you who see this video will know for homework. I want you guys to try out this one and bring it to class, and we'll go over it during class. All right, have a good day, guys, and I will see you.